Hello friends, and welcome to a lecture on Python for chemical engineering. Today we look into a problem of second order reactions. The problem is on your screen. The reaction is A to B going to C is of the overall order 2. The expression or the rate expression is given by minus dCA by dt is equal to kCA CB. Now, if CA is raised to the power 1 and CB is raised to the power 1. So, if we add the orders of this rate of reaction, that is minus dCA by dt, if we add the powers of CA and CB, we get it 2. So, the overall order of the reaction is 2. It is 1 with respect to CA and 1 with respect to CB. The reaction constant is K is equal to 0.3 liter mole a minute. If the initial concentration of A and B are 0.2 mole a liter and 0.3 mole per liter, find the concentration of A and B after 4 minutes from the start. Now, to solve this, let's insert a cell first. So, insert cell below, and let's call our library. So, the libraries that we have to import numpy as np, and then afterwards you have to import ODEInt. ODEInt is the library which helps you to solve differential equations numerically. And then we import matplotlib.pyplot as plt. Now this library helps you to plot the graphs. That's it. The first thing that we have to do is write a model for the differential equations. So we write def so that's the name of our model, and C, that is, it is a vector. That is, C will have two values, that is of CA and CB. So any variable which has more than one value as an array is known as a vector in programming language. So C, and then afterwards this is followed by the variable t, which is nothing but the independent variable. C is the dependent variable. So the first variable in this case has to be the dependent variable. That's it. We put the colon and we start. Now dCA dt is going to be equal to minus 0.3 star CA star CB. Okay, and dCB dt is going to be equal to minus 0.3 star CA star CB. Now, why is this so? That is because stoichiometrically A and B are related, and the stoichiometric coefficient of A and B both are 1. So dCA by dt is going to be equal to dCB by dt. Okay. Now, we also have to write, that is, define two variables. CA is going to be C in brackets 0 and CB is going to be equal to C in brackets 1. Now, why have I written this? CA is C0. Now here, from the array of C, it reads the first value. 0 reads the first value. That is obviously going to be CA. And CB is going to be the second value. So when we enter the array, which I will be showing in a little while, when we enter the array values for C, we are going to enter it in the order where the first value is going to be that of A and the second value is going to be that of B, the concentration of A and B. Now, having completed our model, we write return. Now we have to return here multiple values. So we make an array for it. So dCA dt, comma dCB dt. So we are done. Now let's test it. So we write test and we write equal to REACN second underscore, and then in the array we write the initial concentrations of A and B, that is 0.2 and 0.3, and of course the value of T is 0 to start with, and we just check what is the value of test. So as you can see, test gives us the initial rates of reaction at time T is equal to 0 when the concentration of A and B are 0.2 and 0.3. So far what we have done works perfectly. Now first we define C0. Now C0 is going to be 0.2, 0.3. After that we define the time array. So that is going to be numpy dot, so this is going to be lin. So that will give you an array of values between 0 to 5 and array of values between 0 and 5, and let's say we require 20 such values. So it will give you 20 equispaced values between 0 and 5, where the count for 20 would include 0 and 5. So that's it. We are done. So now let's get the value of concentration. So we write C is equal to ODEint, and then afterwards we write the name of the model first. Then we write the value of the dependent variable. So we enter the array of the dependent variable. So that is going to be C0, the initial values, the starting values, and then we enter the time variable and we execute it. So now let's plot the output of C. So for that, first we write PLT X label is going to be equal to time T in minutes. Y label is going to be CA and CB. Now we plot the graph. So for that we write plot, plt.plot, and we are going to write T, that is the independent variable, and C is the dependent variable. Then we further write the command to plot the grid, and also the last bit of the command, that is plot, for putting up the legends on the graph. So gen, and then we write in inverted commas CA, comma CB. And there. So we have to put this in square brackets. Yes, C and CB should be in square brackets, otherwise it will throw up an warning. Okay, and now let's execute it, and it's done. Now you can see how CA and CB, they vary. So CB starts with 0.3 and CA starts with 0.2, and how its concentration falls with respect to time. Now we want to know the concentration of CA and CB with respect to time, but we want to know it at a time instant of 4 minutes. Now this plot gives you the variation, but it's difficult to read it accurately. So first of all, as you see that the values of CA and CB that are plotted, they are with respect to time, and they are for those times for which we have created a time array. The time array has been created here. That is 0 to t, 0 to 5, 20. Now we have to know what is going to be the value in this array which is closest to 4th minute. Okay, so for that what we do is we find the index. That is, let's say I put t. Now t starting with 0 and ending with 5. This is index 0, this is index 1, value at index of t1. So let me demonstrate that. T0. So T0 is 0, T1. As you can see, the first indexed value is 0.26. So now we wish to know that what is the indexed value, or what is the index of the value which is closest to 4 minutes. So for that what we do is we write np. What we do is np dot argmin. Okay, t minus 4. So if we subtract 4 from this, we will get the value of the difference. Now wherever the difference is minimum, that is the point at which the index is, or the value is closest to 4. Now here too, as we see, the differences initially is going to be negative and then it's going to be positive. So we need to take the absolute value. So what we are going to do is we are going to write np dot abs absolute. Okay, so that's it. And then arg minimum. So this will give you the value for the least index. So we run it and we get the value as 15. Now C at 15 will give you the value of CA and CB. So the value of A is going to be 0.14522 and the value of B is going to be 0.24. Now let's go to the graph and have a look at it. So as we can see here, 0.124, sorry, 0.145, and that's very much as seen in the graph, and 0.24. So this is 25 and 0.24. So as you can see, 0.24 and odd, and it is here, but it would be difficult to read from the graph, and this way we have read it directly. So that was how we solve a problem of second order reaction using Python. So hope you have enjoyed this lecture, and hope you will also find it useful in solving your homework problems. If you have liked this, do subscribe and like my channel. More such videos would be coming, and in the comment box do write what would you like to have as a video made also. That is, if you would like to have a video made on a specific topic on numerical methods in chemical engineering, or application of Python in chemical engineering, or you would like to, learn about how to write a certain kind of program to solve a certain type of problem in chemical engineering, do let me know. I'll try my best to put up such videos if the demand is high. Okay, so what is the best way of checking that you have learned this? Well, the best way of checking that is that I'll throw up a problem here. Now change the K to, instead of 0.3, change it to 0.2 and see what is the answer you're getting after running this program. Okay, and put the answers in the comment. So that would make it a bit interesting. So, if you compare your values with somebody else who has put it on the comments, then okay, you're on the right track. Okay, and I will be also watching such comments, and I'll give my own suggestions in case you fall, if you have any problem in executing these programs. Okay guys, keep watching and keep subscribing and liking. Goodbye. Have a great day.